Third graders, today is a big day where we are going to make the leap from working with fractions less than one to fractions greater than one. So this is something that's really new to us, and we'll take our time. I'll explain it in class, I'll explain it here, and we'll spend some time in the next couple of days going over this as well to make sure that we really develop a good understanding, because I know it's new. It's something that takes some kids a little bit of time to understand. And so I'm here to, if you have questions, but also we'll take it slow and we'll go over it a bunch of times too. Let's take a look at, let me talk to you first, like on my whiteboard, and then we'll go ahead and look at the problem set. Let's get a basic understanding of why we can have fractions greater than one. So we know that fractions less than one look like this. And one, there's a lot of lag here when I'm around that today. So we might have a square, and we can split that square into 4 parts. And we could say that this is a chocolate bar, I ate 1/4 of the bar, I ate 1 out of the 4 sections. But we can also have fractions greater than 1. Before I do that, let's even back up. I can have fractions equal to 1. We've talked about that before. Pretend again I have that same bar. Oh, sorry guys, that my pen is lagging big time today. It's making it really tricky. All right, so I have that, and I have this, and pretend that line's not there. It's this really give me a hard time today. I eat that piece, I eat that piece, I eat that piece, and then finally I eat this piece, and I've eaten 4 out of 4 pieces. I ate 4/4. I ate the whole candy bar. And the reason that we can have something greater than 1 is we could say, for example, that I ate 6/4. Now remember, fourth, the denominator is I'm gonna write 6/4. The denominator is the number in one whole, number of parts in one whole. So in my one whole candy bar over here, each whole candy bar, one candy bar equals 4 pieces. So this is saying that each whole has 4 pieces, but this is how many I ate. I ate 6 pieces. So all right, I ate 1, 2, 3, 4. Uh-oh, I don't have 6 yet. So I need to go into an entire another candy bar. Let's try that again. That wasn't the correct size. This isn't either, but close enough. So I have to bring in a second candy bar, and I'm going to eat 2 pieces of that. So as you can see, I ate 4 pieces from the first and 2 pieces from the second. So this right there does not change to 8 because I now have 8 total pieces. The denominator is the number of parts in one whole. So there's still only 4 pieces in that whole, and there's 4 pieces in that whole. So the denominator is always going to stay 4 in this case. The thing that can change is the numerator. I can eat more than 4 pieces. I just need a second bar. All right, let's go ahead and take a look at our problem set where we don't have to worry about my pen anymore because everything's already drawn for us. All right, so on here, this is, we've done this, I think, 3 times now, maybe even 4, where we have a unit fraction, the total number of shaded, and the fraction that's shaded. So the unit fraction here is 1/2. That's saying that each piece here is 1/2. So that's 1/2 of a whole, that's 1/2 of a whole, that's 1/2 of a whole, so on and so forth. So in this case, we're looking at 1, 2, 3, 4, 5, 6, 7, 8. We're looking at 8ths. So my denominator is 8. Again, it doesn't matter how many holes I have. Each little piece is 1 out of 8 pieces in that whole thing. So again, this could be like, we could think of this as a pizza. kind of a square pizza. And each of these pieces is one piece out of that one whole pizza, 1/8 of that pizza. The number of shaded units in this, let's see, we have 7 there, we have 8 here, that's 15 shaded units. So this becomes my numerator. My denominator doesn't change. I still have 8 pieces in every hole. So this, look, I have 16 individual pieces here total, right? The shaded and unshaded, there's 16 total pieces, but my denominator is not measuring the total number of pieces. It's measuring the number in one hole. There's 8 parts to each of these holes. So my denominator stays 8. My numerator is 15, right? We use 15 pieces, each hole having 8 pieces. Let's move on to the next one where we go even beyond the number 2. So we have 1, 2, 3, 4, 5, 6. Each of these is 1/6. That's 1/6. That's 1/6. That's 1/6. That's 1/6. Each of these pieces is 1 out of 6 in a hole. You can see that there's 6 pieces in one hole, 6 pieces in this hole, 6 pieces in that hole. Shaded, we have 12, 13, 14. We've shaded 14 pieces total. So that's our numerator. And our denominator remains 6 because there's 6 pieces in every hole. So we have 14/6. Now, you could look at a fraction like this and instantly know it's above 1, because as soon as the numerator is bigger than the denominator, that means you have more than one whole. In this case, you have more than 2 because you have more than double the whole. 1, 2, 3, 4, 5. So then we have 1/5. Each section in here is 1 out of 5 of a whole, 1/5 of a whole. We have 8 total shaded in, so we have a total of 8/5 shaded. That means this is the number shaded, and the denominator again is parts in one hole. That's the key. The denominator is always parts in one hole. That is the thing that you're going to hear me say over and over and over and over. You're going to get sick of it. I'm going to say it so much. But the denominator is the parts per one whole object, like whatever it is that you're splitting up into parts. It's how many parts are in that one thing. So again, look here. Look at that one. There are 4 parts in this one whole, which means my denominator is 4. I can even go over here and fill this one in. My denominator is 4 on both of them. Unit fraction means we put 1 in the numerator. Over here, I have to figure out how many are shaded. So 4, 8, 9. There are 9 shaded. So I have 9/4 shaded. Again, if the numerator is less than the denominator, that means we have less than one whole. If the numerator is equal to the denominator, we have one whole exactly. And if the numerator is larger than the denominator, then we have more than one whole. Last one on the front here, we have, you can see thirds, 1/3. I'm automatically going to go make thirds my denominator on this last part because there are only 3 parts to every whole, so it doesn't matter how many are shaded in. The bottom number is 3. The denominator is going to be 3 no matter what else I do. 1, 2, 3, 4, 5, 6, 7. 7 are shaded, so I have 7/3 shaded on this problem. All right, let's move on. So we saw one way to represent that. Let's look at another way. The directions here say estimate to draw and shade units on the fraction strips, and then solve. So the first one is done for us. Let's spend some time looking at that. It says 5/3, which then they wrote out in numeric form in numbers, 5/3. Now, 5 is larger than 3, right? So if 5 is larger than 3, that means we have more than one whole. We have 1, 2, 3, 4, 5, 6 parts total, right? Because we have two holes with 3 in each, and 5 of those are shaded in. Now you might say to yourself, Mr. Brunel, why do we even have to draw that one? Can't we just draw it like this? Well, the thing is, once we have established what one hole is, every other hole has to be the same size. We can't just draw one that's that includes 2/3 and leave off a third, because that hole wouldn't be the same size as this hole. And we need to compare things that are the same size. So on this one, 8/6, well, I'm going to write that out first, 8/6. And the 6 parts tell me that each hole needs to be split up into 6 pieces. So I'm going to split into thirds first, and I take each third and split that in half. And I'm going to do the same thing over here. Split this into thirds, split each third into half, or half each third. Now I have to color in 8 of them. Well, 1, 2, 3, 4, 5, 6. So I've done 6 and I need to do 8, which means I need to do 2 more. 7, 8. I have now done 8, 6. Each hole has 6 pieces in it, which means I got my first 6 here, and then I had to go into a second hole to get my 7th and my 8th pieces. And we can do something similar with this 7/4, where we split this up as such. And we say, all right, that's 1/4, 2/4, 3/4, 4/4. 4/4 being one hole, 5/4, 6/4, 7/4. And I've done 7 out of 4, which means I've done 7 pieces with each hole having 4 pieces in it. Okay, we can move on from there and do the reverse of this. The shading part's going to be the same, but they give us 6/5, which I just need to write out as 6/5. And then I say, okay, I can divide this into 5 pieces. And I need to color in 6 of them. 1, 2, 3, 4, 5, 6. Again, my numerator is larger than my denominator, so I have more than one hole. And I cannot stop there. I can't, I can't cover all those up and say, look, I have a hole and I have one more 6th. But if I don't show the other 5 pieces here, I'm sorry, 4 pieces here, right? The other 4 empty, unshaded parts, then that just looks like a smaller hole, which doesn't match this hole over here. Right? So I have to show that this is 1/6 of this hole. 1/6, 1/6, 1/6, 1. If you can't say that that's 1/6 if you don't show the other portion of it. So we have to draw out both full holes in order to do this sort of work. This last one is 5/2. So I'm going to split each of these in half. Now this one we're going to go beyond 2, because look, 1/2, 2/2, 3/2, 4/2, 5/2. So I have 5 shaded halves. Right? Think of this again as candy bar. You're going to give some friends each half of a candy bar, right? So I go to the store and I say, oh, all right, I'm giving 5 friends half of a candy bar, each half of a candy bar. How many candy bars do I need to buy? All right, well, friend 1 gets a half, then friend 2 gets half. Oop, that's 1 whole candy bar. Friend 3 gets a half, and friend 4 gets a half. Oop, that's 2 whole candy bars I have to do. Then friend 5 gets a half a candy bar, and I have half a candy bar left over as well. So I've done a total of 3 whole bars I had to buy. You can't go into the store and say, I'd like to buy half a candy bar, right? So you have to buy the whole thing and then break it apart and give it to your friend. Mrs. J baked 2 pans of brownies. Let's move this down so you can see a little better. Mrs. J baked 2 pans of brownies. Draw the pans and estimate to partition each pan into 8 equal pieces. Easy enough. 2 pans of brownies. Each one has 8 sections in it. Okay. Her children gobbled up 10 pieces. Shade the amount that was eaten. Okay. They ate 1, 2, 3, 4, 5, 6, 7, 8. And then we have to go to our second pan because we can't fill in anymore over here. We've eaten, all the kids have eaten all those. 9, 10. They ate it. They ate 10/8 of the brownies. Oh, and that's what the last part says. To draw a fraction, or write a fraction to show how much they ate. They ate 10/8, meaning they ate 1 whole pan and they ate 2/8 of the second pan. 8/8 plus 2/8 equals 10/8. So that's pan 1, pan 2, right? They 8/8, they ate the whole thing for pan 1, and they ate 2/8 of pan 2 to get to 10/8, which is what they ate altogether. All right, like I said in the beginning, I understand that this is a new concept. It can be a challenging concept. We're going to spend a lot of time talking about this. That happens every year. So if you find this challenging at first, don't worry. It typically is something that's a little bit challenging for third graders to understand, which is why we take it slow. That's why we talk about it a lot. That's why we go over it multiple days and in multiple different ways. So stick with it. You're doing a great job. And I know that if you keep working hard at it, then you will be really successful with fractions greater than one whole.